Today's video is about the triangle inequality. Now, to demonstrate what the triangle inequality is, let's draw a triangle. So a triangle is a unique three-sided polygon, and we will label the side lengths x, y, and z. Now, there's an interesting property of this triangle and all triangles, and that is the fact that x plus y is greater than z. And we can kind of think about why this is by imagining if we were to kind of flatten the top two sides of the triangle and we were to line them up alongside z, we would see, right, that it would be longer than the side length of z. And kind of in the other direction, if x plus y was less than z, then we would see that when we line them up, the side lengths are actually not long enough to form a triangle. Now, in this spirit of connecting, let's also consider the case where x plus y equals z. And if we were to think about what that would look like, it would just be a straight line, essentially. A triangle would not be able to form, but it is important to take into account this case because this will help us with determining other properties of the triangle inequality. So, for the purposes of this, let's say that x plus y is greater than or equal to z for the triangle inequality to hold true. Now next, let's try to think about this in another way. Another way to think about this fact is that instead of x, y, and z being side lengths of a triangle alone, they can all be vectors. So we can draw a diagram using vectors. So we write x as a vector, and then coming off from it, we write y as a vector. And if you're kind of confused about this notation, the important thing to remember at this point is that a vector is an arrow. So we see that this vector starts at this point and points in this direction, and then our y vector starts at this point and points in this direction. And we define the sum of two vectors, right, to kind of be what the path would be if we say, call it from tip to tail. And so by definition of vector addition, this vector down here is the vector x plus the vector y. Now, similarly to the triangle inequality, right, we can see that clearly the length of this vector x plus the length of this vector y, right, is greater than the length of this sum of the vectors, right? And again, we can see that if this were to be completely flat, then they would be the same. So kind of in a similar vein of what we said before, right, we can say that the magnitude of x plus the magnitude of y must be greater than or equal to the magnitude of x plus y. Now, another way to generalize this idea is instead of thinking about magnitudes, we can think about absolute values. So perhaps we can make the claim, right, that instead of thinking about the magnitudes, we say the absolute value of x plus the absolute value of y is greater than or equal to the absolute value of x plus y. Now this idea is a little bit more difficult to demonstrate, and so we're going to actually have to go through and prove this idea. So let's take a look at it. And let's start with the absolute value of x plus y, or the absolute value of x plus the absolute value of y. So let's think about this. So we have the absolute value of x plus the absolute value of y. Now what if we were to square this, right? So we square this entire quantity. Well, we can see that if we were to square this, right? This is the same thing as saying the absolute value of x squared plus 2 times the absolute value of x times the absolute value of y plus absolute value of y squared, right? And that strategy is by foiling this more complex sum. So one thing we can think about is the absolute value of x squared, or the absolute value of x squared, is the same thing as x squared, right? And we can think about this. The difference between an absolute value of a number versus just that number is that the absolute value, right, will be the positive version of whatever that is, right? So if it's positive, then they'll be the same number. But if it's negative, then taking the absolute value of it would kind of be like multiplying it by -1. Now, think about it. If a number is squared, it will always be positive, right, no matter what. And if the difference that you have is you're sometimes multiplying it by -1, well, -1 squared is 1. So therefore, when you're taking the square of an absolute value, it's the same thing as just taking the square of that number. So we can conclusively write that the absolute value of x squared, right, is equal to x squared. And similarly, right, we can extend this to say that the absolute value of y squared is also the same thing as y squared. Okay, great. So now, right, we now have x squared plus 2 times the absolute value of x times the absolute value of y plus y squared. So what else can we do here? Right, because we still have this absolute value of x. So let's think about it. Again, we're comparing the absolute value of x to x, right? So if x is a positive number, the absolute value of x will be the same. But if x is a negative number, the absolute value of x will kind of be like multiplying by -1. So you jump from the negative version to the positive version. So therefore, we can say that the absolute value of x is greater than or equal to x, right? And again, it's greater than, right, if x was negative, and it's equal to if x is positive. And again, in a similar vein, we can say that absolute value of y is greater than or equal to y. So great, we can make a similar statement, right, here. We can say that, well, this is going to be greater than or equal to something really similar. But instead of having absolute values, right, you're just going to have what's inside. So let's write that. This expression here is greater than or equal to x squared plus 2xy plus y squared. And again, to understand, right, why this statement is true, we can think about it that this x squared and y squared, it's the same in both. So then what you're just doing is you're adding this 2xy, right? 2 absolute value of x, absolute value of y. And here it's just 2 times x times y. So again, right, absolute value of x is greater than or equal to x. Absolute value of y is greater than or equal to y. So this product is greater than or equal to this product. And if that's the only thing that's different between these two expressions, right, we can definitively conclude that this is greater than or equal to this. Okay, but we've shown that this is true. That doesn't help us show that this statement is true, right? So we're going to have to do some algebraic manipulation, right? So here, again, this is the same thing as this squared, so we're just going to write it back just for convenience purposes. So we have the absolute value of x plus absolute value of y squared, right? And is greater than or equal to. And this we can kind of think about if we look here, or if we try to factor this out, right, we would see that this is the same thing as x plus y squared. So again, we can see if we were to FOIL this out, we would get x squared, right, plus 2xy plus y squared. And based on what we've shown here, right, that if we square a number, then it's the same thing as the absolute value of that number squared, right? And the real numbers are closed under addition, fortunately for us. So we can say this right here. This is the same thing as the absolute value of x plus y squared. And this is actually really nice what we have here, right? We have two positive numbers, right? They're squared. And so because of this, we're allowed to take the square root of both sides. And we would get the absolute value of x plus the absolute value of y is greater than or equal to the absolute value of x plus y. And thus, right, this shows that our triangle inequality, right, we can show it, we can think about it geometrically, we can think about it using vectors and magnitudes, and we can also think about it using absolute values. And this fact definitely helps us, and this will help us in the future with certain proofs and ideas that we want to show. Now, there's one more thing I want to show you. What if, instead of the absolute value of x plus y, we had the absolute value of x minus y, right? So, absolute value of x minus y. How does that relate if we were to split them up? Well, we can kind of think about it. X minus y is the same thing as saying x plus negative y. And x plus something, right? We know that this absolute value is less than or equal to the absolute value of x plus the absolute value of that something, right? So therefore, right, the absolute value of x plus the absolute value of that something, and in this case, that something is negative y, right, is greater than or equal to the absolute value of x plus negative y, right? And we look at our absolute value of negative y. Well, again, that's the same thing as the absolute value of y. Because again, the absolute value returns a positive version of something. So multiplying by -1 in the absolute value doesn't actually change what that value is. So we can simplify this even further and say that absolute value of x plus absolute value of y is greater than or equal to absolute value of x minus y. And there we go. So this is it so far on the triangle inequality. Thank you very much for watching.